Okay, good morning. My talk this morning will be about a very recent development I've been doing on the 2.0 branch. It's about the document replication extension. It's part of the 2.0 release, but it's not being built by default, but we will make an extension out of it. But we'll be talking about it a bit later. Before I talk about the contents of the extension, I have some mandatory things to tell, of course. Well, about me, I'm a long-time XSDB contributor, and like 7-8 years, maybe longer. You might know me, might not know my name, Dennis, but you could know my alias on the mailing list. I'm very active on the mailing list. I'm a co-founder of Exist Solutions. That's the company you can call for your XSDB challenges, feature components, etc. And I am author of several parts of the Exist database, like the web dev interface. I did the XML validation stuff, and well, the talk of today will be about the document replication extension. So what will be the agenda for today? Actually, the document replication extension is a replacement of an older version called the clustering feature. So I will have a look back on what we had previously. And then I will dive into the replication extension itself, like design, how you can configure some metrics. In the end, there will be a conclusion and some question and answers appropriate. So, back in the early days, starting with 2005, we had this clustering feature, and basically what it did, it was really copying documents from Exist instance to Exist instance. You have a look at this. It's exactly what it did. Every Exist instance would copy a new document or an updated document to every other each other XSDB instance. And the library under the hood used was Jacobs, which is a very good library these days under the hood of Jacobs. And well, in certain aspects it worked just fine, but there were some problems. First of all, it was created in 2005 and it was actually abandoned in 2005 as well. There were no patches, no updates, or no significant updates since then. And there were bugs, serious bugs, and they were not solved. And they were very, very complex to get them solved. And as you saw with the multiple relation in the previous slide, it does not really scale. If you add another XSDB instance, it will be a magnitude of extra replication steps between each of the instances will be happening. So it's not good. It doesn't scale, and actually it was very intimate with the XSDB core. And every change in the core would mean changes in the clustering feature. And like Adam worked on the XMLDB stuff last week, the very core classes. You would have to spend lots of hours on there as well. So that's not good. And the other thing is it's really complex to configure. And I have an example of how the configuration looked like. Look, it's kind of JGroup's configuration thing, and if you can find your way in here, good luck. I'm pretty sure this one or this one is maybe not good. So, that's a really bad idea. So I came up with the XSDB replication extension. As I said, it's introduced for XSDB 2.0. Well, it's actually in there for about a year now. But since we were not able to release earlier, it's part of 2.0. It's a project by Exist Solutions. And it's kindly sponsored by the State Department, the US State Department, and by the University of Richmond. And the goal of the extension, and I actually mentioned before, is well, actually we want to replace the old clustering function. And if we would replace it, it would be very good to use all kinds of standards XSDB standards. We'll focus on that a little bit later. And let's use industry standards, because if you use really industrial standards, things will be easier. And very important, let's make the configuration more simple. Then we saw the horrible thing just a slide ago. And well, it's not really a goal, but we decided to rename the function from clustering to replication, because the name of clustering is kind of overloaded. And in my backup slides, we have some other things we could do with the term of clustering. So how would it look like? For scaling up XSDB, because that's in the end the purpose. And we have a few ways of doing this, and this is the way we actually want to do in the first place with the application extension that we have. It's basically not that difficult. We have a kind of publisher, which may be called the master, which if the actual document changes are done in this XSDB instance. Then there's something in the middle that's called the broker. That does the actually routing, and we have identical XSDB instances which only listen to what's coming in from the broker and gets the data in. And on the other side, well, we have the big evil internet, where we put a load balancer in between, so the load will be distributed nicely across the existing instance. And with this is at least one of the ways of getting a more scalable solution. So, of course, we had some requirements we wanted to put in the extension. First of all, it must be a kind of a natural fit into the XSD designer, into the XSDB database. Of course, we want to have it scalable, reliable. It must be asynchronous. It must be a kind of loose coupling between what the masters and the slaves, or the subscribers and the publisher. And well, as I said, let's use industry-based technology, because that will make things easier in the end, and we would not be coding everything by ourselves. So what would that mean for exist? Well, it's rather simple. It must be pluggable. So we have to use triggers, which has been, Dimitri has been working very hard on it. It's the building stone, and Adam, of course, sorry. It's a cornerstone of the Exist product. It's very, very, very powerful. And if we would make anything, let's make it an extension, so it's kind of really a pluggable solution. So for the transport, we have lots of kind of potential solutions for it, alternatives. But since we are already in the Java domain, it would be most logic to choose from this domain in the first place. So let's have a look at the Java Enterprise DNS service. And why would we choose that? Well, at least it's proven technology. You have the freedom to choose your own implementation. There are all kinds of implementation, commercial, open source. Because of that, there's no vendor locking. And if you need to set up your network of XSDB instances, well, you just could call your favorite Java Enterprise solution provider, and you will be able to make a coupling between all the instances. So there's not really an XSDB geek needed to have it get working. In this project I've been working on, I chose for the ActiveMQ message broker. That's the man in the middle. Well, it's open source, it's popular, it's very flexible, and even you could look into it with other languages, because it has an open protocol under the hood. And so basically you could use any .NET or Python or Perl client to put documents into the pipeline and have it distributed. Okay, so the JMS thing is about clients, which is either publisher or subscriber, and there's a kind of a message broker. And if we do it like, see like this, both client and the publisher are normal XSDB instances, and the one in the middle is the ActiveMQ broker, which basically copies the message coming up from the publisher to the clients one-on-one, transparently. So, if we would have a look at the publisher side of XSDB, that would mean that we would be using the collection trigger. And this thing is well known. This is the file also used to define indexes in the XS database. So it's very easy to do. And on the subscriber part, well, we have a kind of process that needs to listen to incoming packages. Therefore, we use the freshly added startup trigger. It's created by Adam. And there's about 1 line, 2 lines in the startup conf you have to add, and then if you started up the database, the functionality will be there. And about the green thing, the message broker, yeah, well, I won't focus it into this talk because it's vendor specific. You can tune all kind of parameters in there. But for the ActiveMQ, well, basically the default configuration should be okay. But if you use large documents on many instances, you might be interested in increasing the broker cache, but that's also one line in configuration. So, in the end, how does it work? Well, it's kind of document-based. So, if in the publisher instance a document is changed or updated or deleted, whatever, the complete document is wrapped up. It's actually compressed. It's put on the line to the broker copies it to the subscribers. Subscribers receive the document, and it will just insert the document as it is, as it would do it with a normal document upload. Good thing about this is that you will always have consistent documents in your complete network of XSDB instances. There's one little problem, and that's where Leif Jordan found out that if you do an X update or a bulk X update of small parts of your document,
or not,
it will be copying for every update complete document into the pipeline, and that would be if you have large documents, it can be very painful. But we will be thinking of how to work around here. Okay, some metrics. I did some exercise with 2 types of documents, and the schema of about 1 megabyte, and then the built.xml file of exist. And as you see, well, although the number of documents per second in the first line it might not be impressive, but it's still like about 1.5 to 2 megabytes per second we can do on replication documents. And it does not matter how many subscribers you have, either 1 or even 100, this rate will be approximately the same. And I think that would be quite good. Okay, so it's working, but software is never ready. So we have some other ideas we could work on. Starting and stopping the software could be still a bit polished. The changes in the metadata are still not replicated. Immediately made some changes, but I forgot to implement the thing, so that will be done in the next few weeks. We will be working on this update problem, and as Adam suggested, we have to think of securing the data channels, because at this moment everybody could put in documents into the broker and would end up on the location in the subscribers, and that's in the end maybe we do not want to do. Other ideas we have is to create an XQL extension, so you could even hook up in a more transparent way into the enterprise environment. I will probably make it. The extension at this moment is part of distribution, but there's nothing wrong in making a pluggable XR with it. XS2.0 has this pluggable feature with XRs. It can add a work UI for monitoring and maybe some management, and in the end we could be will be talking about this today. But what's then the federated search? Well, basically, I won't go into much of the details, but basically, again, we have in the middle on the right side, we have a basically identical XSDB instance, but in the broker we have the kind of configuration which copies certain documents, in this example per collection, into a certain one specific XSDB instance. And in the front end you have the federated search engine, which can be a modified XSDB engine, which during query time will just consult on the backend backend XSDB instances for its data. I think it will be very feasible, but it will take some time to get this working. Okay. Conclusions. I think with the extension we have really a good successor of the original clustering function. I was able to decouple the functionality from the core, so the design is rather clean. By using the standard broker, it's very scalable. It doesn't matter if we have 5 instances of XSDB or 100, it should perform approximately the same. Good performance. We have lots of enterprise level opportunities, and well, at least there are always some. In the end, we have always some room for additional improvements. But, well, the community will give us feedback. We will making improvements all the time. Okay. That was it. Questions?
Well, I'm looking to this. I actually missed 2 things that you usually find in these kinds of setups.
Yeah.
Is what happens when something changes in one of the subscribers. It's not replicated. And the second thing is, what about session replication over the subscribers? Because you don't know where your request will end if you have a...
One of the problems you have if you would have all this, I already chose for one master several slaves, so there's the intention is in the design I had is that you won't make any changes on the subscriber side.
It's a read-only database.
Actually, it would be possible with the same broker to have every instance as a kind of subscriber and publisher, and you can block having some messages going to specific subscriber. I did not test it too much, so I didn't want to focus on that. But there's one big problem, and that's about document locking. If you would have one instance and you have you have the Oxygen editor and you have one document block, how would you replicate these locks over your complete network? I mean, the delivery of the messages is guaranteed, but the timing is not guaranteed. It can be like seconds or milliseconds or tens of seconds, and with that it would be not really working.
No.
But that's indeed the weak spot. But one of the problems of scaling up a part of the existing instances should be covered. But yes, it's not the holy grail.
No. And is there any plans then for session replication? Because that's another problem with these kinds of setups.
I did not have focus on this.
Okay.
I think what we looked into.
Yeah.
Very near into the future.
So what if the master should fail or should be corrupt in some way? Would that matter for the subscribers in some way? Would that be a problem?
Basically no, because the communication decoupled by complete documents, and if database, the master would be corrupted, and most of the time corrupted document would not be sent over the network. So it would be a local, I think it would be a local.
But then there would be in some way out of sync, just to...
Yeah. So another thing we just